When you stream a movie or send an email, the whole thing feels kind of invisible, right? Like it's all just happening in the air. But behind that screen, there's a massive physical world of servers and cables, and it's using a truly shocking amount of energy. So today, we're going to dig into some fascinating research from the ICCE 2023 conference, which is all about using AI to tackle one of tech's biggest and most hidden problems.
Okay, so let's just start with a super simple question. We all talk about the cloud, but have you ever really thought about where the internet actually lives?
Well, it lives right here, in hundreds of these huge, often windowless buildings called data centers. They're just packed to the gills with servers, all humming along 24/7. This is the real physical infrastructure of our digital world. And man, does it have a serious appetite for electricity. And that gets us right to the core of the issue, the internet's hidden footprint. This isn't just a small problem, it's a challenge the entire world is now starting to face. And it is a huge challenge. As our world gets more and more connected every single day, the energy demand from these data centers is just skyrocketing. So figuring out how to make them more efficient is absolutely critical if we want our digital lives to be sustainable. So what's being done about it? Well, it turns out there's a massive global hunt for solutions. Researchers are exploring every possible angle you can imagine. And just to give you a sense of the scale of this effort, the researchers behind this particular project started by looking at a huge pool of existing knowledge. Between 2018 and 2022, they found nearly 133,000 scientific papers related to energy efficiency in data centers. But here's the wild part. They didn't just skim the surface. No way. After a super meticulous review, we're talking filtering by keywords, titles, abstracts, the whole shebang, they whittled that enormous number down to just 57 of the most relevant studies. That is an incredible amount of focus. And when they looked at what was in those 57 papers, they found all sorts of different approaches. You see everything from little hardware tweaks to better resource management, but look at the numbers for AI techniques and reinforcement learning. It's pretty clear that a lot of researchers think intelligent software is a major part of the solution. And this brings us to one specific, really smart approach that caught our eye. It's an idea that combines two powerful technologies, and it's called the elastic tree. The first piece of the puzzle is something called software-defined networking, or SDN. The best way to think about it is like this. A traditional network is like a city with fixed roads, but SDN is like having a central traffic control system that can reroute everything on the fly. It puts a software brain in charge, which makes the whole network flexible and way, way smarter. The second piece is the elastic tree itself. You can think of it as an energy-saving manager. It uses that smart SDN brain to watch the flow of data in real time, and when it sees parts of the network that aren't being used, it intelligently powers them down, and then wakes them right back up the instant they're needed again. So you've got this great idea. How on earth do you test it? I mean, you can't just start unplugging things in a live data center, right? You have to build a virtual one, a kind of digital laboratory. And this is such a crucial point. Experimenting on the live internet is an absolute non-starter. It would cause chaos. So to test this elastic tree idea safely, the researchers had to simulate an entire data center network right there on a computer. And they built this virtual lab in 4 basic steps. First, they used a tool called MiniNet to create the digital blueprint of the data center. Then, they put in their elastic tree logic. That's the energy-saving part. Third, they added the brain, a controller called Floodlight, to direct all the virtual traffic. And finally, they used a viewer to watch the whole system work. And here's what that virtual lab actually looks like. This isn't a room full of physical wires. It's a software blueprint. Every one of those little icons you see represents a piece of the network. A switch, a host, the controller, all connected and running in a completely virtual space. This is the cockpit. It's the dashboard for the Floodlight controller, that central brain we were talking about. You can see it's actively managing a little network of 5 switches and 10 hosts. It really is like an air traffic controller for data, making all the smart decisions for the entire system from one spot. So why go through all this trouble? Well, because it represents a fundamental shift. Traditional networks are decentralized and inflexible. With SDN, you get centralized, programmable control, which makes the whole network dynamic enough to do amazing things, just like this elastic tree concept. All right, so this brings us to the big picture. What does research like this really mean for the future of green AI? I absolutely love this detail. This isn't some finished product coming out of a giant corporation. It's actually part of a master's thesis by Hasib Aslam, a student at the Virtual University of Pakistan. We're getting a real-time look at research in progress that could literally shape the future of the internet.
So let's just pull this all together. The big takeaways are pretty clear. The internet's energy consumption is a massive hidden problem. But scientists all over the world are exploring tons of solutions. Ideas like Elastic Tree show us how AI and SDN can intelligently save power. And none of it would be possible without these virtual labs that let us test out these radical new ideas safely.
All of this points to a really exciting and vital question for our digital future. So, what is next for green AI?
Ultimately, it seems like the very technology that drives the internet's growth, AI and complex software, might also be our best hope for taming its environmental impact. This research is just one piece of a much bigger puzzle, but it leaves us with a pretty powerful thought. Could our smartest technology end up solving its own biggest problem?